budget and work some in the summer. All right, so with 1.3 notes, we just talked about doing this investigation question, and now we're going to fill in some blanks here. Some people like step-by-step processes for doing questions like this. I kind of like that. So here's a step-by-step. Identify the actions. Okay, so first thing is to identify the actions within some story problem, and then you want to the one specifically that would suggest an operation or operations. The next step would be to define one or more variables, and then those represent unknown pieces of information, right? Typically what the question is asking you to solve for, and then represent the actions using the blank and the operations, variables again. So you actually don't need your laptops for this. You can kind of put those away for now. I don't think you'll need them even before the end of the class period. Here's a brief question for us. You start with $20 and you save $6 each week. Budgeting, finances. So necessary to have some math skills for that. So what algebraic expression models the total amount that you actually save? Step 1, identify some actions. So the fact that you start, there's an action, you start with a certain amount of money, $20. And then the word and, the universal word and in math translates into addition, right? And then here's another action. You save, and each week, that clues us into something that's going to be changing, right? Each week it's going to be different, so you can kind of foresee a variable coming into play there. So let's check. We did step 1, identify the actions and suggest operations. Step 2 is define some variables. Any suggestions on a variable? Gigi.
The weeks.
Weeks, good. So let's use W. Weeks. So the number of weeks will be represented by W. Let's use T then for our total, because it says that's kind of what the question is asking, the amount that you actually save. So we write an equation. The total piece, if it tells you total, that's usually the thing to the left of the equal sign. So T equals, we start with something, it's very obvious, that would be what we would write down first. Start with $20. $20 doesn't change, we call that a constant. Good. We talked about that one on Wednesday, and then this number of weeks associated with the $6, 6W. Week 1, you're just going to have that $6 and the $20, so $26. Week 2, you would have 2 times 6, $12, and 20 that you started with, $32, and so on. So that's our variable expression. We're going to kind of take a step back in time and practice substitution, where we're given an algebraic expression. They give us some values for the variables, and we substitute those in and solve. So a question like this on a test might say evaluate. So it just means plug in the values for the variables. So we have 7 times A, 7 times negative 4 plus 4, and then plus 3 times B, or 5, and then minus 8. Negative 4 and 4 is 0. 3 times 5 is 15. Take away the 8. So kind of back of my head, I'm doing order of operations there, right? Things in parentheses go first, then I can multiply, and then I add. PEMDAS, remember that? Parentheses, exponents, multiplication and division in order, and then addition, subtraction in order. So this next one, x and y are both equal to 1. So 1/2 plus 1 squared is going to equal 1 times 1 is 1. That's our exponents part. We do that first. So 1 plus 1/2 is 1 1/2. And lastly, stepping it up here, 2 times parentheses 6 squared, and then the -3 squared. This is, some of you are going to do this correctly. The -3 has to go in parentheses before you square it. I squeezed that in there. The -3 needs to go in parentheses before you squared it. Here's why. In your calculator, it actually will give you an answer of -9 if you don't put parentheses. -9 is definitely not the answer for anything squared. Anything squared is positive, right? A number times itself, whether it's a negative times a negative or a positive times a positive, it's going to be a positive answer. So that's obviously not what you wanted. The way that the calculator works, it just needs those parentheses in there. So there's that side note. And then divide by the 3. So we get 2 times 6 squared is 36. And then minus the -3 squared, which we know is a positive 9, divided by 3. 36 minus 9 is 27. Now we could go 2 directions with this. Since it's a fraction, I can think about it as reducing as a 27 over a 3. 27 divided by 3 is 9. And then I can take that 9 and multiply it by the 2 and get 18. That works better for my mental math skills than doing 2 times 27 and getting 54 and then dividing that by 3. You could also use a calculator for that. So there you go. There's 3 examples like that, and example 3 puts it all together for us. Any basketball fans? Okay, so here's how it works. So in a basketball game, you can get 2 points just for shooting and scoring from like in a regular position on the field, on the court. So you get 1 point though if you just shoot a free throw. There's not really, anybody blocking your shots for that. But then if you shoot and score from outside of the 3-point marking on the court, it's 3 points. So we can set up a situation here. This is all described right there. By defining a variable or a few variables. How many variables are involved here? So we have 3 different ways to score, so there's 3 different variables. So first of all, there's a 2-point shot. It depends on how many 2-point shots you make, right? So there's a variable kind of coming into play. So let's define that as x. So x is going to be our 2-point shots. Let's do y for our 3-point shots. Let's do z for our 1-point shots. 1 point. And we'll do t for total. So it says, what algebraic expression models the total number of points that a basketball team scores in a game? So total, we can start there, right? Total equals, and the expression for our 2-point shots, 2x, right? So I get 2 points for each 2-point basket that I score. And then 3 points for each 3-point shot that I make, and then 1 point for each free throw that I make. So there's an algebraic expression that represents that scenario. Now the question goes on to ask us, well, what if you scored 10 points, or 10 2-point shots, 5 3-point shots, 7 free throws? How many points do you get in total? So then we just substitute those in. See how they set us up in example 1 and in example 2? 2 times 10 plus 3 times 5 plus 1 times 7. So 20 and 15 and 7. Who's got it? 42. So 42 points. So no UC Bearcats basketball fans in here? Yes, Mr. Herb, 1? Just 1, just 2. It's okay. It's okay. That's right up there. There's a UC Bearcat in case you want to know what one looks like right there. He's wearing a basketball outfit, I think, actually. All right, example 4. The last little tidbit here that you'll need as part of your assignment for this section is a refresher on simplifying algebraic expressions. So there's a couple key pieces there. You have to combine like terms. So remember, like terms, same actual variable and to the same exponent value. So since we have a couple of x squareds here and then we have a couple of y squareds here, I kind of like to underline them or do something unique to set them apart so I remember which ones go with which. The other key part to this is noticing the operation directly in front of your expression. So since there's a minus sign in front of the 4x squared, it stays together, okay? So this is actually 7x squared minus 4x squared, or 3x squared. And then 3y squared plus 2y squared is 5y squared. Part B then, the distributive property is needed because when we simplify an algebraic expression, we shouldn't have any parentheses in the end. So the negative sign is what we distribute first. And it only goes to the values inside the parentheses directly next to it. So negative 3k and then minus m. It's going to be a minus sign since the negative times the positive is going to be a negative. So we can choose a minus sign there. And then the 2k, we're adding here, plus 2k. But then we have a 2 times a negative 4m, so that's going to wind up being a minus 8m. And then the last step is to combine those like terms. So we've got the negative 3k and the positive 2k. So that's going to be a negative 1k, or just negative k. We don't need to write the 1 when it's next to a variable. And then the negative m and the negative 8m, or minus 8m, is going to be a minus 9m.